All right. So section 110, first sentence is highlighted. An electrical switch is a device that is manually or automatically operated to make or break an electrical circuit, operating within the rated current and voltage of a switch, of the switch. Gotta make sure your switches are rated for the voltage and amperage that you're applying to it. Skip a sentence, and I got the last sentence, the last two sentences in that paragraph highlighted. Standard electrical switches should not be used to interrupt a circuit that is subject to short circuit or overload conditions. Fuses or circuit breakers are designed to prevent such conditions. That's why you don't have light switches turning on motors and stuff like that. Or at least you shouldn't. That don't have any overload protection or anything like that. Page 2, switch classifications. It's a good idea to, I can talk about this till I'm blue in the face, but in my experience, the easiest way to kind of learn like the SPST, single pole, single throw, double pole, single throw. So you have two connections being made with one flick of a switch, double pole, double throw. So this is going to have two different connections that can be made each time you switch it. So this is switch to the top. So that's one connection, switch to the bottom, it's another connection. So this is single throw because whenever I open it, it's not connected to anything. So I can talk about that and talk about that and talk about that. But I feel like the easiest way is for you to kind of like look through this stuff and go through the different ones. And like this is going to be a decent section to read. But I mean, it's got poles right here is the number of circuits in the switch. And then throws is the number of different closed positions. So I'm looking right here, throws, number of closed positions, I've only got one. Number of closed positions here, I have two. So that makes this the double throw. But just wrap your mind around that. Switch contacts 1, 2, 1. Second paragraph, second sentence is highlighted. Contacts are often coated with a conductive material to prevent oxidation and ensure low resistance contact point. I showed y'all that contactor out of my air conditioner with the pitting and stuff. So there's like a white grease, like a dielectric grease that they can put in that stuff. And that, like if it has the grease in there, like it will eliminate that arc, which will help with the pitting and also help with the contact. So a lot of times you'll see that white grease. I think we talked about like a synchronous time switch in this class, like the switch that can turn on and off lights or sprinklers or stuff like that. We talked about that. That it had that white grease in the back of it. I think there's a picture of it in the previous section, but that's what they're talking about. 1, 2, 2 pole and throws of a switch. First sentence is highlighted. The pole of a switch is the place where the movable contacts are attached. Second paragraph, first sentence is also highlighted. A single pole switch will make and break only one conductor leg of a circuit, whereas a two pole switch will make and break two legs of a circuit, and so on. Third paragraph, third sentence. The poles and throws of a switch are often abbreviated as shown in figure 4. Out to the side of that one, I wrote ways of classifying switches. Ways of classifying switches that's where they're talking about like that DP-DT or DPST or SPST. Up at the top right of the page, where it's got those knife switches, I've got an online test question for this right here, where it's got look up on the board, this double pole, single throw schematic diagram. I've had an online test question for that. So I've got this highlighted. They show you a picture and they ask what type of switch it is. (130) switch applications 131. I've got the last sentence on the page that goes into page 4 highlighted. Except for a rotary or joystick switches, that can have many poles and multiple throws. Most push button, rocker, and snap action switches have the same pole and throw designations as toggle switches. So all these different switches that you see up at the top here, besides the joystick and the rotary, like this, these are just like push buttons and switches are kind of the same thing. But push buttons can be momentary, switches can also be momentary. It's the same thing. You're just making connections inside that device, and that device can either hold them in or connect two things together. It's just a matter of what is happening inside of here. So you have this, I guess I call that a push button switch. Looks like a limit switch, but you have toggle switches. Like you can have two position toggle switches where like one side is momentary and the other side is switched on. You can have all different types of like connections inside of these push buttons or switches. It's just a matter of what the need is and how it's made. 132 float and level switches. Second sentence is highlighted. Float switches are often used to start and stop motor-driven pumps that are used to empty and fill tanks. So you can have a bunch of different types of floats. So if you look up here on the board, you can have a float switch to where all your electrical stuff is out of the tank, and you just have some type of buoy or flotation device here. And as this goes up, a switch is made right here. As it goes down, the switch is up. It's kind of like the one on your toilet, except this actually has like electronics inside of it. The one on your toilet is completely mechanical, that's shutting off a valve. But pretty much the same thing. Like whenever this is down, this pump will turn on. And then whenever it goes up, it'll shut this pump on. This is what you're going to see for the symbol for a float switch. Like that's a symbol for a float switch. You'll also have different types over here. This is what I dealt with a lot whenever I was at the steel mill. Usually this has like a three wires coming out of it. It had a common, and then it had a normally open and normally closed. So whenever this is facing down, however you wanted to wire it up, like one contact was made, and then when it flipped up, it made the other contact. These are nice. They're cheap. They're easy to switch out. The only disadvantages is if you have like a turbulent tank, like if you have water that's like instead like this is how it's supposed to be, like where the water flows in and pushes in from the bottom. It's not always like that. Sometimes the water or whatever it is coming in from the top, and the top of that is all like that. This would not be a good choice for a tank like that. This would be a better one. Or they'll even talk about at some point we'll talk about bubblers if we haven't already. Pressure switches, same thing. Actually, going back to this picture, like you'll see, like this is just this float switch right here. Like there's one of those, you'll be messing with it next semester. The other big blue trainer in the back, the temperature one, the hot water tank, the heater element. If there's not enough water in that tank, and it has a float that's exactly like this, and this is just a little magnet right here. So it flops down, magnet's not made. Whenever the level goes up, the magnet's made and it switches on. If there's not enough water in that tank, the heater element won't turn on for that tank. And that's because if there's no water in that tank and I didn't have this in there and I just turned on my heater, that heater would burn up because it has no resistance to getting hotter and hotter and hotter and hotter. It'll just burn up. So you put a float switch in a series circuit so that if that float switch is not made, that heater won't turn on. Pressure switches, same thing. You'll have these on the motor trainers. I've usually been skipping them, but these are the symbols that you'll see for normally closed, normally open pressure switch. So pretty much the same thing. This has diaphragms in it. As the pressure goes up, you can make a normally open, normally closed contact. It's like an air compressor, right? Turn an air compressor on, it fills up. As the pressure builds up, you set it to 120 psi, gets to 120, and then it would open up and turn off the motor. And then once it drops below 120 or whatever you have it set at, it'll close and the motor will kick back on. Different way of operating does the same thing, switches on and off. Page 6, limit switches. Limit switches are used in a bunch of different places. So these are the schematics, and like usually I tell y'all when the symbol is what I've seen it to be. Sometimes they aren't, sometimes they are. These are, like everything so far, this is what a limit switch looks like. Where it's normally open, normally closed, or held open. So you can have limit switches like this, or if you're on the little, no, you're on the smaller motor tree. You make it to limit switches yet? The little push buttons?
Yeah.
So that's a different version of a limit switch. And you can even have these micro switches. Anybody ever seen one of these? Like a little arm or something like that. So you ever open up your oven door and the light turns on? There's a little micro switch somewhere where not super obvious that as soon as you open up that door, that switch opens up that turns the light on. So this is a version of a limit switch. Super cheap. Like I've worked on the coffee house here in town. I've worked on their the ovens like they have in Subway. Like they had like a little trick with these is sometimes like if there's doors and stuff, like you can shut the door and it's not making the switch, because pretty much this arm, you can see this, I can't zoom in anymore, but this arm just pushes down and it's usually just pushing on a button like this that's just turning it on and off. So sometimes this arm loses some spring back or something like that. You can take a little piece, you can take some needle nose pliers and just bend it a little bit out and then it works. Like it just pushes more tension against that door and that happens a lot. Like that's a very simple fix. Like if you use that as a fix, make sure you like order another switch or have another one on hand. Like that's a temporary fix, because like I've done it before and left it and then it goes bad like a week later and I should have had a switch on hand or something like that. But just know that like for the time being, you could bend that up a little bit to where it would make. 134, top right of the page, first full paragraph, first sentence. In general, the operation of a limit switch begins with when the moving machine or part strikes an operating lever which activates the limit switch. .135 electronic switches. So you can have SCRs, silicone controlled rectifiers. So these are switches that can handle large amounts of current and switch them on insanely fast. These are used in variable frequency drives to smooth out a rectified waveform. That's getting too far into it. But you just need to know that they can switch power on and off very quickly in large amounts of power. Which that's the highlight. Got ahead of myself. Second paragraph, first sentence in 135. The basic purpose of the SCR is to switch large amounts of power on and off. I've heard of two, hasn't been down here, but it's been up north, like job interviews, and they asked my buddies that interviewed, like, what is an SCR? Two different companies, stuff like that. So it might be something to keep in the back of your head. Like, just remember, like the guy said, he's like, all he had to remember was silicone controlled rectifier. So not a bad thing to learn about. They're kind of like, you don't really get into them till you get into controls quite a bit, and messing with drives and stuff. And even if the drives that I've worked on, I've never replaced an SCR. We just replace the whole drive and then send it out and stuff. But it's good to know how they work and what they do. Page 8 and 9. Page 8 just shows more of the pressure switches. Page 9, photoelectric devices. So photocell. Let me give you the highlights and then I'll talk about them. First, sentence of 140 is highlighted. Light sensitive devices, sometimes called photoelectric transducers, alter their electrical characteristics when exposed to visible light or infrared radiation. Photocell switches. 141, the sentence that starts in the bottom left and finishes out at the top right is an online test question. Basically, a photocell is a variable resistor in which a resistance value depends on the amount of light falling on the device. Another highlight is this next paragraph, first two sentences. The resistance of the photoconductive material shown in figure 18 varies inversely with the amount of light that shines on it. In other words, as more light hits the photocell, the lower the resistance of the photoconductive material becomes. Where do you use photocells? So as light comes, it switches, it switches. So where would you use that?
It'd be like on newer trucks. You start your lights
cars and stuff like that. Like if you have automatic lights on your car, there's usually a little bubble on your dash. That's your photocell, right? Security lights. I have security lights on my house. I got them flipped on. They don't come on during the day because it has a photocell. Street lights. Street lights, if you notice, a lot of times they have a little cap on the top that's blue. That's the photocell. Photocells go bad. They make those caps where the quarter turn, pop them out, pop a new one in. So this is like something physical is actually happening to this photocell to switch something on and off. So photocells are used everywhere. Cheap device that's just used to turn stuff on and off. Anytime you hear dusk till dawn lights, that's referring to something that will turn on at dark and then off during the day. Page 10 and 11. The more photocell, this is showing like how a photocell works with a light. So your power goes into your photocell, then comes out. So the switch is actually made inside the photocell. Already talked about that. Photocell applications. These are big. Like you use these. These were used everywhere in the steel mill for automation, for how to make stuff move in certain ways. You can use them for count. Like this is used as a counter. So every time one of these cans passes through, usually one side of this is the emitter, one side is the receiver. So whenever the receiver doesn't see the emitter, it counts. It says one can. Then it'll see itself again, then it'll count again. They can use the same thing for this. So if you have like a big roll of paper and it lasts for hours at a time, but you're not paying attention to it, you can put up a light beam that maybe whenever this roll starts out, it's up here somewhere, but as it decreases, like this light will shine through, it'll see it, and then maybe something on their HMI will pop up, say, it's almost time to switch the paper out, something like that. So they're not scrambling to change paper or whatever the material is. You can use them for that. We used them on conveyors. Where like a big roll of steel would come in and we had like 4 different spots. So if there wasn't anything in the second spot, it would turn on all the rollers behind it. Once that second spot got filled, it would stop that set of rollers and keep rolling till the third spot's filled, keep rolling till the fourth spot's filled. So we had four different light beams that would control like some type of automation. You have a bunch of different types of photocells. You'll be doing I just got a photocell. These are also called proc switches. Well, no, these are photocells. These aren't proc switches. Where you can, like they have reflective, retro-reflect. There's different modes that you can have for these things. So instead of having an emitter and a receiver, I can have an emitter and receiver in one component, and I can put a piece of reflective tape so it emits and receives back on the same side. And then whenever something breaks that, it'll count, or it'll say this doesn't have a top, or something to that effect. There's tons of different types of photocells and how they work and whatnot. Solar cells, 142, second paragraph, second sentence. Solar cells, also called photovoltaic PV detectors, generate a DC voltage and current. Key in on DC voltage and current that is proportional to the amount of light that is absorbed by the cell. Anybody have solar panels on the roof? Neither. Solar panels generate DC voltage. Can't use DC voltage in your house, right? Your plugs and stuff don't use DC voltage. So it has to go into a rectifier. If you know somebody has solar panels on the roof, none of that power goes into their house. All of it gets rectified. And you ever seen somebody with one? They have like a green meter and a regular meter. That regular meter is or the green meter is reading how much you're sending back to the grid. What's up?
Got any WD-40?
I don't think so. No. It's just sending it back to the grid, and that green meter is just tallying how many kilowatt hours that you're selling back to the like Entergy or whatever. But you're not using any of that. The only way you could use it is if you got batteries and you store the power. You have no way of storing power. Like when I go, like I've done run mission trips and stuff in Mexico, and they don't have power at one of their sites, and you can go buy $100 solar panel and a car battery, and we put the solar panel on the roof and had the car battery inside, and that way they have lights at night. But you have to have, for solar panels, you have to have some way of storing the power. So batteries, like I know, like I've seen stuff about Tesla walls and Tesla solar and stuff. I haven't seen any of it here, but like I think their goal is to try to store some of that energy. But solar energy is DC from solar panels. Page 12, infrared devices, 150. First sentence is highlighted. Any object that is not at a temperature of absolute zero, which is 0 degrees Kelvin, negative 273 degrees Celsius, or negative 460 degrees Fahrenheit, will emit invisible electromagnetic energy in the form of IR. That's why like IR like the military uses IR vision and stuff like that, because it's very hard to eliminate all of your temperature, right? You can't get stuff to negative 460 degrees Fahrenheit. That's going to affect you in a different way. Motion detectors, 151, second paragraph, first sentence. Figure 25 shows a set of floodlights controlled by IR motion detector switch. So if you look up here on the board, this has two different types of switches in it, right? Like we talked about before, it's got the photocell switch. Photocell switch makes it to where this won't do what? Turn on during the day, right? So this switch, whenever daylight is showing on this, will be open. So whenever it goes dark, this switch will close. But if this is a motion light, if there's no motion, this will stay open and it'll still be off, right? But if this sees any type of motion, if this sees anything that's not negative 460 degrees Fahrenheit, this will kick on if it's also dark. That makes sense? So this is a series circuit.
Also daylight.
What's that?
Also daylight.
Also daylight. What do you mean?
Motion.
This is the daylight part of the switch. But daylight, this won't make it turn on because this will be off by the time it gets daylight. Is that what you're saying?
So the motion detector won't work during.
During the day? Yeah, well,
That's
it will work. Like this switch will open and close. The light will not turn on because this switch will be open during the day, right? You have to have both of them in order to get the 120 volts out. You also have the manual override switch. If you ever have installed or messed with one of these, you slide this thing all the way to one side and it says test. This is the test. So you slide to one side and this gives it power. Then you switch it. Then the other side of the switch is like keep the light on for 30 seconds, 60 seconds, whatever. But then the power would be going over to this side. Online test question, third paragraph in 151, first sentence. When the light controller contains both the photocell switch and the IR detector switch, it operates as if there were 3 single pole, single throw switches involved. Everybody see that? 3 single pole, single throw switches. Industrial process IR sensors. 152, the first 2 sentences are highlighted. IR sensors are used in the control of temperature sensitive industrial processes, including paper production and stack temperature monitoring in cement and petrochemical facilities. They are particularly useful when the temperature probes is impossible or impractical. Everybody's seen one of these, right? Everybody got their head scanned with these at one point during COVID. That's what these are. They're infrared temperature sensors. So somewhere where these are insanely useful in a plant is where you have like automatic valves overhead or somewhere where it's hard to get to or hard to see. The way you can use this, like you might suspect that a valve's not working, right? You can shoot that and they have a laser on them and you go on one side of the pipe and the other side of the pipe. If they're the same temperature, more than likely the valve's open, right? If they're different temperatures, that's saying the valve is closed and nothing's flowing through the pipe. So you can take that and shoot different spots and see different temperatures and whatnot with those. Obviously, they make them to where like they're sensitive enough to take temperatures of your head and stuff. I guess they're sensitive enough. I had all kinds of feeling. 94, you're good. You're dead. But very useful to have one on hand. Page 15, fiber optics. 160. Last sentence in the first paragraph was highlighted. Glass fibers are used when the emitter source is infrared light, and plastic fibers are used when the emitter source is visible light. That's becoming more and more of an old statement. More and more fiber is going to plastic. Because plastic is a lot more it's cheaper, but it's also more durable. Pulling glass fiber sucks. If y'all seen the stuff where they offer the fiber cords here? I don't know when they're gonna do it again, but they got a grant from Cox last time and they offered like the fiber course. They have 3 different courses and they're about $700 a piece. And Cox donated money because they need people to run fiber. And it was like $50 a class to get certified in connecting fiber. And if you ever see that, like next time I see it come up or something like that, and if there's I would highly, highly, highly recommend that. Like, it is very easy to get a $40 an hour job for fiber. We're boring, but they're running fiber through St. Bernard right now. Like, fiber's going to be everywhere. But very.
Yeah, I can't wait.
Benefit. I can't either. It's stupid that we can't get higher than 50 meg and right outside of New Orleans.
You can pay for more too. That's what they don't tell you.
I can't get any more.
No, you can pay for more, but you won't get it.
Oh yeah.
Like they'll give you the plan because it's coming. But they don't.
No. Online test question. Next paragraph, second and third sentence. Figure 28A shows the through beam method in which the light is emitted and received with individual cables. The target either breaks this light transmission or allows it to pass from emitter to receiver. So these 3, you need to memorize, learn, whatever. They're going to have all 3 of these on on the test. The next highlight is also an online test question in the top right of the page. First sentence in the top right, in the retroreflective method, the reflected material is installed to bounce the emitted light back to the receiver. Online test question.
What was the second one? What is that? Oh, no, my.
Top right, that would- first full sentence in the top right, online test question. Immediate next sentence is another highlight. The diffuse method uses the target to diffuse or reflect the emitted light from the cable. So all three of those, you're gonna need to know all three of those for the test. So the through beam, got an emitter, receiver, brakes. Retro-reflective is gonna have like a piece of reflective tape or some type of mirror or something like that. The target breaks that, then it's gonna switch, and then you can have the diffuse method, which will just, you'll use the target itself to reflect the light back. So you have to have different, you have to have certain types of material in order to use the diffuse method, usually some type of metal or something that's gonna reflect the light. 170, proximity sensors. First sentence is highlighted. Proximity sensors are used to detect the presence or absence of an object without ever touching it. These are usually what proximity sensors are gonna look like. Usually they're gonna be 2-pin or 3-pin, depending on what they are. Very, very, very common piece of equipment, or type of switch. So this just, these can work in different ways. They can have capacitive or non-capacitive types. So an object moves in front of this, it senses that object and it switches state, or it switches the contacts inside of it. Everything's solid state inside of this, but it switches back and forth. I don't know how many calls I got where all I had to do was go wipe the grease off the front of one of these and everything took off and worked fine. Good operators. If you have a lot of these and somebody knows their equipment, they're pretty good about wiping stuff off and doing that and at least have an idea of what's going wrong. But these can sense the presence or absence of an object. Next paragraph, first sentence is highlighted. The most popular type of proximity sensor is the line-powered inductive type, which operates on the eddy current field oscillator or echo principle. The next sentence is also highlighted. Next two sentences going into, actually, the rest of the paragraph is the next highlight. Going into the next page. The oscillator consists of an inductor capacitive or LC tuned tank circuit, which generates an AC magnetic flux as it oscillates and emits a field from the face of the switch. When a metal object is placed near the magnetic lines of flux, eddy currents are induced in the metal object, which in turn disrupts the turning of the LC tank circuit. The oscillations die out or are killed. When the oscillations die out, the integrator signals the trigger to switch the output of the proximity sensors. That's a lot to say. Like it's kind of obvious what happens in this. Like you generate an electromagnetic field. What's that?
Level number 4.
Are you done with that one?
Yeah.
Then we'll be done for tonight because I'm at the end of my chapter with them. So we'll be done with them tonight. Oh, you said
Yeah.
mine? Oh, I thought you meant for the next one. Yeah, get the highlights right.
Yeah.
I thought you were trying to ask for another pack.
Yeah.
So pretty much this just generates an electromagnetic field, and if something breaks this electromagnetic field, it switches state. Right? Questions? Remember, like a lot of this stuff, all this is just different devices that are switching stuff on or closed to open. Right? Everything does the same thing. It's just works in different ways for controlling in different ways. So you got the section review, you got the module review, you got the practice test. Any questions? Did I already say that? Thank you. Have this done at by the time you get to class Tuesday. I will go over it individually. I'm going to check those stuff, and then after that, I'll let you take the test, then we'll be in the lab after that. Good? All right. See y'all on Tuesday. Have a good weekend.
Am I good to come in early too? No, it's for early too. Yes.
It's-
For the day that they're supposed to have the trunk or treat, said that we just want to class in a few. Okay, I don't know, canceling it or not.
We'll see, cause that, like, I might have to help out with that. Yeah, I'll let y'all know next week. All right. If you do, like, I can say that I gave y'all stuff to do at home. Or I'll just say that I'll give y'all stuff to do.
All right.
Yeah.
I could go straight to